asteroid hurtling towards the Earth is something real-life scientists are preparing for at NASA.
Really believe that astronauts or the space scientists are figuring this stuff out.
Right now, astronomers are tracking an asteroid with the highest impact probability we've seen in 2 decades. And instead of the risk decreasing, it's actually going up. This isn't science fiction. It's happening right now. A massive space rock, officially named 2024 YR4, has shot to the top of NASA's asteroid risk list. Estimated to be between the size of a football field and the Statue of Liberty, this asteroid is traveling at tens of thousands of miles per hour, and calculations show a 1 in 43 chance it could collide with Earth on December 22nd, 2032. Most asteroids start as a concern, but are quickly ruled out. 2024 YR4 is different because every new observation increases the odds of impact. That's why NASA, the European Space Agency, and observatories worldwide are in a race to determine whether this asteroid will pass safely or hit us. Could this be the asteroid that finally forces humanity to take action, or will it be another close call? Stick around, because what we've uncovered might shock you. On December 27, 2024, astronomers at the ATLAS telescope in Chile spotted a faint dot of light moving against the backdrop of distant stars. At first, it seemed like just another asteroid, one of thousands discovered every year. But as scientists tracked its movement, they realized this was no ordinary space rock. Now named 2024 YR4, this asteroid is among the most concerning near-Earth objects ever detected. Estimated to be between the size of a football field and the Statue of Liberty, it is traveling at tens of thousands of miles per hour. What makes it alarming is its trajectory. According to NASA's latest calculations, 2024 YR4 has a 1 in 43 chance of colliding with Earth on December 22nd, 2032. That 2.3% impact probability makes it the most significant asteroid threat since Apophis in 2004. Most newly discovered asteroids follow a predictable pattern. Initial uncertainty decreases as more data is collected, and the risk of impact typically drops. But 2024 YR4 is different. Instead of decreasing, its odds of impact have been rising, an unusual and concerning trend. To measure asteroid threat, scientists use the Torino scale, which ranks objects from 0 to 10. A level 0 asteroid poses no risk and is either too small or guaranteed to miss Earth. Level 1 is normal, with no cause for concern. Levels 2 to 4 require attention but are unlikely threats. Levels 5 to 7 indicate serious regional or global impact risks, while levels 8 to 10 mean a certain impact with catastrophic consequences. Most asteroids never surpass level 1. Even Apophis, first discovered in 2004, only reached level 2 before being ruled out as a threat. 2024 YR4, however, is currently at level 3, making it only the second asteroid in history to reach this classification. A level 3 ranking means that while an impact is not yet certain, it is a real possibility requiring continuous tracking. NASA, the European Space Agency, ESA, and observatories worldwide are working to refine its trajectory. If future observations rule out an impact, 2024 YR4 will drop to level 1 or 0, putting concerns to rest. If the impact probability remains or increases, it could become the first asteroid in modern history to reach level 4 or higher. Scientists are now racing to collect as much data as possible before April 2025, when 2024 YR4 will become too faint to track. After that, it won't be visible again until June 2028. Meaning this is our best chance to determine whether Earth is in danger. Could 2024 YR4 eventually be ruled out as harmless, like Apophis? Or is this the first asteroid that will force humanity to act? On December 27, 2024, astronomers at the ATLAS telescope in Chile detected a faint moving dot in the night sky. At first, it seemed like just another asteroid, one of thousands discovered each year. But as scientists tracked its motion, they realized this object followed an unusual trajectory, one that brought it uncomfortably close to Earth. This asteroid, later named 2024 YR4, was quickly classified as a near-Earth object, NEO, meaning it orbits the Sun in a path that sometimes brings it close to our planet. However, further calculations revealed something far more concerning. Its orbit intersects with Earth's future path, raising concerns about a possible impact. A TLAS The Asteroid Terrestrial Impact Last Alert System is part of a global early warning network for asteroids. It consists of multiple telescopes positioned around the world, scanning the sky every night for potentially hazardous space rocks. ATLAS was designed to detect objects like 2024 YR4, early enough for scientists to track their movements and assess their risk of collision. As soon as ATLAS detected 2024 YR4, it alerted observatories across the world, prompting immediate follow-up observations. Within hours, telescopes in North America, Europe and Asia locked onto the asteroid, refining its position and calculating possible future paths. Then, something unexpected happened. When astronomers first detect an asteroid, its orbit is uncertain due to limited data. Typically, early calculations suggest a range of possible paths, and as more observations come in, the risk of impact almost always decreases, eventually ruling out a collision. But 2024 YR4 is different. Instead of its impact probability going down, each new observation made an impact seem more likely. Initially, the chance of collision was low, but as more telescopes gathered data, the numbers began to rise. By early 2025, NASA estimated that 2024 YR4 had a 1 in 43 chance of striking Earth on December 22, 2032, a 2.3% probability, making it the most significant asteroid threat in 2 decades. This increasing risk level has puzzled astronomers. Normally, refining an asteroid's trajectory narrows its possible paths and eliminates Earth as a target. But with 2024 YR4, every adjustment has kept Earth within the danger zone. Scientists now face a critical challenge. They must continue tracking 2024 YR4 while it remains visible, gathering as much data as possible before April 2025, when it becomes too faint to observe. Once it disappears from view, astronomers won't be able to study it again until June 2028, when it re-emerges. That means this current observation window could be our best chance to determine whether Earth is truly in danger, or if, like many asteroids before it, 2024 YR4 will ultimately be ruled out as a threat. If 2024 YR4 were to collide with Earth on December 22, 2032, the destruction would be catastrophic. The extent of the damage would depend on where it strikes, its speed, and the angle of impact. While not large enough to cause a mass extinction, the energy it would release is comparable to a large nuclear explosion, with devastating regional effects. Current trajectory models suggest 2024 YR4 could impact the Eastern Pacific Ocean, parts of South America, the Atlantic regions of Africa, or South Asia. If it were to hit the ocean, the biggest threat would be tsunamis. A deep-sea impact could generate waves hundreds of feet high, flooding coastlines thousands of miles away. The 2004 Indian Ocean tsunami, which killed over 230,000 people, was caused by an undersea earthquake. An asteroid impact could be even deadlier. A land impact would be even worse, creating a massive crater and flattening everything within hundreds of miles. A direct hit on a major city would instantly destroy buildings, ignite firestorms, and send a shockwave powerful enough to shatter windows and collapse structures across a vast area. The extreme heat from the explosion could cause widespread fires, further increasing the destruction. Scientists estimate that 2024 YR4 would release between 10 and 50 megatons of TNT, making it comparable to the Tsar Bomba, the most powerful nuclear weapon ever detonated. Unlike a nuclear bomb, however, an asteroid impact would also launch millions of tons of dust into the atmosphere, potentially blocking sunlight and affecting global weather patterns. History provides clear examples of how destructive even smaller asteroid impacts can be. The Chelyabinsk meteor of 2013, only 20 meters wide, exploded in the atmosphere with the force of 30 Hiroshima bombs. The shockwave shattered windows in over 7,000 buildings and injured 1,500 people. If 2024 YR4, which is much larger, were to explode mid-air, the damage would be far greater. The The Tunguska event of 1908 was even more powerful. A 50 to 60 meter asteroid exploded over Siberia with a force of 10 to 15 megatons, flattening 800 square miles of forest. If it had struck a populated area, an entire city would have been wiped out. While 2024 YR4 is not an extinction-level threat, its impact could be one of the most devastating asteroid events in recorded history. Scientists are racing to refine its trajectory, knowing that early detection and planetary defense measures could be the key to preventing disaster. When an asteroid like 2024 YR4 is first discovered, astronomers have limited data to determine its exact trajectory. Early calculations provide only a rough estimate of its future path, leaving a large margin of uncertainty. As more observations are made, scientists refine the asteroid's orbit, narrowing down its possible locations in the future. This process often leads to a temporary increase in impact probability before it ultimately drops to zero. A good way to understand this is through the flashlight beam analogy. Imagine pointing a flashlight at a wall in a dark room. When you first turn it on, the beam is wide and blurry, covering a large area. You can tell roughly where the light is shining, but you can't pinpoint an exact spot. This is similar to how astronomers first calculate an asteroid's potential path. The initial data suggests many possible locations where it could be in the future, including some that might intersect with Earth. As you adjust the focus of the flashlight, the beam becomes narrower and more defined. If Earth happens to be within that refined beam, it may appear as if the asteroid's impact probability is increasing, not because the asteroid's course is changing, but because our prediction is improving. This is what's happening with 2024 YR4. New observations are sharpening our understanding of its path, and unfortunately, Earth is still within that refined target zone. However, astronomers remain confident that the risk will eventually decrease. This pattern has happened before. The asteroid Apophis, discovered in 2004, was initially thought to have a 2.7% chance of impacting Earth in 2029, even higher than 2024 YR4's current 2.3% probability. But as more data was collected, scientists were able to refine its orbit and rule out any possibility of impact. The same has been true for many other asteroids that initially seemed dangerous, but were later determined to be harmless. Right now, scientists are racing to collect as much data as possible before April 2025, when 2024 YR4 will become too faint to observe. After that, it won't be visible again until June 2028, when it re-emerges, providing another critical opportunity to track its motion and further refine its trajectory. By that time, we will have more advanced observation tools, including NASA's NEO Surveyor, a space telescope specifically designed to detect and monitor potentially hazardous asteroids. While the current numbers may seem alarming, history tells us that the more we observe an asteroid, the more likely it is that the impact risk will drop to zero. But until that happens, scientists will continue to track 2024 YR4 closely to ensure we are prepared for any possibility. For the first time in history, humanity has the technology to defend itself against an asteroid threat. Unlike past civilizations that could only watch as space rocks streaked across the sky, modern scientists are actively developing ways to detect, track, and even deflect dangerous asteroids before they can strike Earth. If 2024 YR4 were confirmed to be on a collision course, could we stop it? The answer is yes, but only if we act in time. In 2022, NASA successfully demonstrated asteroid deflection with the DART Double Asteroid Redirection Test mission. DART was the first real-world test of planetary defense, deliberately crashing a spacecraft into Dimorphos, a small moon orbiting the asteroid Didymos. The impact, which occurred at 14,000 miles per hour, successfully altered Dimorphos's orbit, proving that a kinetic impactor could be a viable method of planetary defense. Building on DART's success, the European Space Agency, ESA, launched the HERA mission in 2024. HERA is designed to study the long-term effects of the DART impact, analyzing how the asteroid's orbit, shape, and structure changed. This data is crucial because not all asteroids are solid rock. Some are loose rubble piles, which could respond differently to an impact. If 2024 YR4 is made of weaker material, scientists may need to adjust their strategy to ensure any deflection attempt is effective. While DART and HERA were major milestones, planetary defense experts are now working on more advanced asteroid detection and deflection methods. One of the most important upcoming tools is NASA's NEO Surveyor, a space-based telescope launching before 2028. Unlike ground-based observatories, NEO Surveyor will scan space in infrared, allowing it to detect asteroids that are too dark or too small to be seen from Earth. If NEO Surveyor had been in operation earlier, it might have detected 2024 YR 4 years ago, giving scientists more time to plan. If a dangerous asteroid is detected early enough, a scaled-up version of DART's kinetic impactor method could be deployed to nudge it off course. However, if the warning time is short, some experts believe a nuclear deflection mission could be necessary. Instead of destroying the asteroid, a nuclear explosion near its surface could push it onto a safer trajectory. With the right preparation, an asteroid like 2024 YR4 could be stopped. The key is early detection, and that's exactly what scientists are racing to improve. The tools are being developed, the technology exists, and if the time comes, humanity may be ready to defend itself from a cosmic threat for the first time in history. Despite the rising impact probability of 2024 YR4, scientists believe the most likely outcome is that it will eventually be ruled out as a threat. History has shown that when an asteroid is first discovered, its trajectory is uncertain, and early calculations can suggest a higher risk than what actually exists. As more data is collected, astronomers refine their models, and in nearly every case, the impact probability drops to zero. A perfect example of this is Apophis, an asteroid discovered in 2004. Initial calculations suggested a 2.7% chance of striking Earth in 2029, an even higher probability than 2024 YR4's current 2.3%. For years, it was considered one of the most dangerous asteroids ever detected. However, as scientists gathered more observations, they were able to rule out an impact completely. Apophis is now known to pose no threat for at least the next 100 years. This same pattern has played out with countless other asteroids. When an object is first detected, astronomers have limited information, and their calculations include a wide range of possible future paths. With each new observation, that range narrows, and Earth is almost always eliminated from the danger zone. While 2024 YR4 is currently the most concerning asteroid in decades, history suggests that as tracking continues, the impact probability will likely drop to zero. Right now, scientists are in a race against time to collect as much data as possible before April 2025, when 2024 YR4 will become too faint to observe. Once it disappears from view, astronomers won't be able to track it again until June 2028. That means the observations being made right now are critical in determining whether this asteroid remains a concern or becomes another Apophis-like false alarm. To refine its trajectory even further, astronomers are searching for past images of 2024 YR4 from as early as 2016. These pre-covery images could provide crucial information about its previous movements, allowing scientists to make even more accurate predictions about its future path. While the asteroid remains at the top of NASA's risk list, experts agree that the odds of an actual impact are still incredibly low. As more data comes in, it is expected that 2024 YR4 will eventually be ruled out as a threat, just like Apophis and many other asteroids before it. Until then, scientists will continue tracking it closely to ensure we have all the answers we need. 2024 YR4 is a reminder that Earth exists in a constantly changing cosmic environment. Asteroids have been colliding with our planet for billions of years, shaping its history and altering life itself. But for the first time ever, we are not just waiting for impact. we have the technology to stop it. With missions like DART, HERA, and the upcoming NEO Surveyor, scientists are proving that planetary defense is no longer science fiction. It's a real and evolving strategy. While 2024 YR4 is still being tracked, history suggests that its impact risk will eventually drop to zero, just like Apophis and many others before it. But even if this asteroid turns out to be harmless, the work being done today will prepare us for the next one, and the one after that. Staying informed is critical. Follow NASA's updates, keep an eye on new discoveries, and stay engaged with the latest advancements in planetary defense. The more we learn about these space threats, the better equipped we'll be to protect our planet. The universe has been throwing rocks at Earth for billions of years, but now, for the first time in history, we're ready to catch them.